Two identical small charged spheres, each having a mass of 10 kg, hang in equilibrium as shown in the figure. The length of each string is 0.60 meters and the angle is 15 degrees. That is the angle between the vertical, okay, and the length of the string. Find the magnitude of the charge on each sphere. So to determine the charge, we're going to use Coulomb's equation, and that is electrostatic force or electric force is equal to Coulomb constant KE times charge Q1 times charge Q2 divided by R square, which is the distance between these two charges. Okay? Since ang hinahanap po natin ay yung charge, so kailangan nating i-derive yung ating formula. And that is by cross multiply. So FE times R squared, that is equal to FER squared equals to KQ squared. Bakit natin ginawa siyang KQ squared? Kasi sabi naman, identical daw po yung charges natin. And then, i-divide natin siya both sides by Coulomb constant KE. Cancel out KE, leaving us with charge squared. Charge squared is equal to FER squared divided by Coulomb constant KE. And then, since ito ay naka-squared, we have Q is equal to square root of FER squared divided by KE. But unfortunately, we will not be able to solve the problem because wala pa tayo nung kanyang electric force at wala pa tayong value ng distance between the two charges. So the next thing na kailangan natin gawin is to determine the electric force. At paano natin yung gagawin? First is we have to identify all the forces acting on the charge spheres. So in this case, meron tayong tension force kasi meron tayong string, pataas siya, and then i-divide natin siya sa kanyang component. We have T sine theta and we have T cosine theta. So this one is the horizontal component of tension force and this one is the vertical component of tension force. Bakit siya T sine theta? T sine theta ka siya kasi nandito yung ating angle. So ang opposite po niya ay yung horizontal component ng tension. At dahil horizontal component po yun, ang gagamitin po natin ay yung sine theta. Dahil siya yung opposite. Okay? And then for the vertical component, kung ito ang kanyang opposite side, ito ang kanyang adjacent side. So kapag adjacent, gagamitin natin is cosine function. Kaya siya T cosine theta. And then we have the gravitational force, which is directed downward. At meron tayo namang electric force. So, papalayo yung ating electric force kasi magkakameron po ng repulsion. Kung magkakameron ng repulsive force kasi parehas nga po yung charge ng dalawang charge spheres natin. Now that we have the free body diagram, we can now calculate po the electric force by using the definition of translational equilibrium where summation of forces is equal to 0. So ngayon, kunin natin yung summation of forces along y is equal to 0. So ano yung forces natin along y? We have T cosine theta minus Fg equal to 0. So positive yung T cosine theta kasi pataas to. And then negative yung gravitational force natin kasi siya ay pababa. Now, itatranspose natin si gravitational force from left papunta sa right at papalitan natin yung sign niya ng negative to positive. So, we have T cosine theta equal to gravitational force. And then, i-divide natin siya both side by cosine theta. So, makakancel dito si cosine theta. So, tension force is equal to Fg divided by cosine theta. And we know that the magnitude of the gravitational force is equal to the product of mass times g, or acceleration due to gravity, divided by cosine theta. Okay? Next, we have summation of forces along x is equal to 0. So, dito naman, lahat ng forces along x. So, in this case, meron tayong t sine theta. Positive siya kasi papunta siya sa right, minus yung ating electric force kasi papunta siya sa kaliwa, equal to 0. Then, we have t sine theta equal to electric force. So, yung electric force po natin, tinranspose natin from left going to right. So, magbabago yung sign niya from negative to positive. Okay? And then, Isasubstitute po natin yung value ng ating tension force dito po sa tension dito sa ating equation ng electric force. So we have here mg divided by cosine theta times sine theta is equal to electric force. Now, mapapansin natin you have sine theta over cosine theta and that is equal to tangent theta. So electric force is equal to mg tangent theta. Now let's plug in the values. For the mass of the object, we have 10 kilogram times 10 times 9.8 meter per second squared times tangent 15 degrees. So let's calculate the electric force. So you have 10 times 9.8 tangent 15 degrees. So we have 26.26 Newton. Okay, so nakuha na po natin yung value ng electric force na kailangan natin sa pag-calculate ng charge. Pero, hindi pa rin natin alam yung distances between these two charges. So, ano yung gagawin natin? Mapapansin natin dito sa ating illustration na yung half nitong triangle na to ay ang distance ay A. So, ibig sabihin, yung distance simula dito hanggang doon ay equal to 2A kasi symmetric naman po itong right triangle dito. So, ang mangyayari, nandito yung ating angle na 15 degrees, tapos nandito si A, tapos nandun si length. So, pwede natin gamitin yung sine function which is equal to opposite over hypotenuse. So, ang opposite natin dito ay si A at ang ating adjacent naman ay yung length. So, para makuha natin yung value ni A, magko-cross multiply lang tayo. So, A is equal to L times sine theta. And then, let's plug in the values. The length of the string is equal to 0.60 meters times sine 15 degrees. So, ang ating pong A is equal to 0.16 meters. So, para makuha natin yung total distance dito sa dalawang charge, that is yung R is equal to 2A. So, we have 2 times value of A, 0.16. R is equal to 0.32 meters. Now that we have the value of electric force and R, we can now calculate the value of charge. By using the equation, Q is equal to square root of electric force times distance or R squared divided by Coulomb constant. Q is equal to square root of 26.26 Newton times 0.32 meter squared divided by 8.99 times 10 raised to 9 Newton meter square per Coulomb square. So, ang value po ng ating charge ay 26.26 times 0.32 squared divided by 8.99 raised to 9. Ang charge po natin ay equal sa 1.73 times 10 raised to negative 5 Coulomb.